Hi, my name is Nur Aida Syukrina binti Tambizi and my metric number is E2483458 and I will explain about this slide. Geography Information System or GIS is a computer-based system used to collect, manage, analyze and visualize spatial or location-based data. GIS helps us understand pattern and relationship based on geographic location, especially in environmental and spatial studies. In this project, we focus on introducing GIS tools such as desktop GIS, using QGIS and WebGIS to show how GIS is used from analyze to map sharing.
It looks like we've just opened QGIS, a powerful open source geography information system. Since we are on the start screen, this is the perfect time to understand how to manage our mapping projects. This section is for starting something new, which is we need to click on the new empty project. By clicking this, it gives us a blank canvas to start importing our shapefiles, satellite imagery or GPS data. It looks like we've moved into a new empty project. The screen we're looking at now is the main QGIS workspace, and specifically we've highlighted the browser panel on the left. We have to click on the browser tab. This is where we connect to and find our mapping data. We have to select XYZ tiles to expand the folder and highlight it OpenStreetMap. Double click on the street map. By double click OpenStreetMap in the browser is to give us a reference of map. Now we have successfully added this OpenStreetMap layer to our project by dragging or double clicking on browser panel. We are now looking at the map canvas. In a QGIS, adding a better layer allows us to view and analyze spatial data like points, lines, or polygons. There are several methods to load our vector data into the project, but we choose by click on a layer menu. First, go to layer menu, then add layer, and lastly add vector layer to open the selection dialog. We are now performing one of the most fundamental tasks in QGIS, which is importing vector data. Vector data represents real-world features using points, lines, and polygons, such as the state boundaries of Malaysia you are currently learning. The first we are looking at represent different levels of Malaysian geography, which is MYS admin 0, usually the international border of the whole country. MYS admin 1, usually the state boundaries, which is Selangor, Johor, Kelantan, Terengganu, and many other states. And lastly, MYS admin 2, usually the district boundaries. Now we are in the data source manager, which is where we tell QGIS exactly which file to display. We have selected MYS admin 1 shapefile. Why the SHP? A shapefile is actually a collection of several files. In QGIS, we always select one ending in SHP to load the entire data set. Once we click open and then add, the administrative boundaries for Malaysia will appear on top of our OpenStreetMap background. By using the same step, we are now adding vector layers to our QGIS project, which is a KMZ files. We also navigated to GADM41 MYS1 KMZ. This is a Google Earth format that QGIS can read just like a shape file. In this case, the administrative boundaries of Malaysia. We are now successfully added the Malaysia administrative boundaries to our map. We can now see the red outlines of the states overlaid on the OpenStreetMap base layer. Now, when we look at on the right bottom, we change from browser to the layers. Next, right-click on MYI's admin 1 in the layers panel and select Open Attribute Table. This opens a spreadsheet-like view of every state boundary that we have loaded. Next, right-click on MYI's admin 1 in the layers panel and select Open Attribute Table. This opens a spreadsheet-like view of every state boundary that we have loaded. Once we open the attribute table, along the top of the attribute table, click on Toggle Editing, which is the pencil icon, to start making changes to data, such as renaming a field or correcting a value. Select all of the other states that we are choosing, then let our chosen states remaining there. Also, delete the other states that we didn't choose. Now we have moved from simply viewing data to editing and cleaning our dataset. This is a vital step in GIS to ensure our project contains only the information relevant to the Selangor Forest Reserve, which is my project. Now we deleted all the others information that shows the null information. Now click on the add field icon and change all the information there. Name change into Forest Reserve and length change to 7, number position change to 1. Do not turn off the toggle editing yet and change the Forest Reserve information into our data that we got. Once again, right click on the MYI's admin 1 and then click on the rename layer to change the name of the MYI's admin 1. Once again, right click on the Forest Reserve that we changed and open the layer properties to change how the data looks based on its value. We switch the symbol type to graduated. This allows QGIS to automatically change the color of an area based on a numeric value, in this case our Forest Reserve data. For the color ramps, we selected a red color ramp. This is often used in GIS to create a heat map effect, where darker colors represent higher values like higher forest density or larger reserve areas. By clicking Classify, QGIS broke our data into 5 distinct ranges, creating a visual legend that makes it easy for anyone to understand the map at a glance. Now it shows how the plugins manager, which is how we add a new features to QGIS, which is by using Quick OSM. We are looking at one of the most popular plugins in the GIS world. Instead of searching for files online, Quick OSM allows us to download data directly into QGIS using the Overpass API. For example, we can query for every forest or river within the Selangor boundary and it will automatically throw those features on our map. By clicking Install Plugin, it will add a new magnifying glass icon to our toolbar for these quick searches. Now it shows us installing and using the Quick OSM plugin, which is a powerful way to get live environmental data. We access the plugin manager to install Quick OSM. We open the Quick OSM interface to search for specific geographic features and use the land use and nature/nature/nature reserve preset. We set the key to leisure and the value to nature reserve for the area of Malaysia. Click Run Query will automatically find and download every officially mapped nature reserve in Malaysia from the OpenStreetMap database and add them as new layers to our map. Now we are installing QGIS to web. This is an incredibly useful tool that will allow you to turn our QGIS project into an interactive, clickable website, which is using open layers or leaflet that we can share with others without them needing to install QGIS. Now we have moved from basic map viewing into advanced data management, analytical styling, and plugin-based data sourcing. We have successfully isolated our target region, created a custom data field, and are now exploring QGIS ecosystem to pull live environmental data for our Selangor Forest Reserve project. Now we have provided our successful move through the entire workflow of a QGIS project, from starting with a blank map to performing data analysis and preparing for a web export. This is the result of our map. That's all.
Hello and good day. My name is Nurul Atika binti Atman and my metric number is E2483406. And for the comparison and evaluation part, I will explain the differences between desktop GIS and web GIS based on usability, scalability, and accessibility. So first, desktop GIS is mainly used for advanced spatial analysis and detailed data processing. In this project, desktop GIS is very useful for accurately mapping the distribution of forest reserves in Malaysia. However, it requires software installation, high-performance computers, and technical skills. This makes it less accessible, especially for non-technical users. On the other hand, WebGIS is more user-friendly and can be accessed easily through the internet using web browsers. It allows forest reserve data to be shared with government agencies, researchers, and the public. This helps to improve awareness and decision-making related to forest conservation. However, WebGIS has limitations in terms of advanced analysis, and its performance depends on internet connection and server stability. In terms of evaluation, both systems have their own limitations. Desktop GIS is more powerful but less scalable, while WebGIS is more accessible but limited in analysis capabilities. As a potential improvement, integrating desktop GIS for analysis and WebGIS for visualization would provide a more effective approach. This combination can support better forest reserve monitoring, data sharing, and sustainable forest management in Malaysia.
Next, let us go through application to environmental or spatial problem. Forest reserves play a crucial role in environmental sustainability by preserving biodiversity, regulating local climate, safeguarding water catchment areas, and minimizing environmental hazards such as soil erosion and flooding. In Malacca, rapid urban expansion and change in land use have placed increasing pressure on forest landscapes, exposing forest reserves to fragmentation and encroachment. As a result, understanding the spatial distribution of forest reserves is essential for supporting effective environmental management and informed spatial planning. This project addressed the uneven spatial distribution of forest reserves in Malacca, Malaysia. Without effective spatial analysis, monitoring forest coverage and identifying environmentally vulnerable areas becomes challenging, increasing the risk of environmental degradation and unsustainable land use. The first step is aid data. Geography Information System (GIS) was employed to analyze and visualize the distribution of forest reserves in Malacca using 2019 spatial data source from data.gov.my. GIS software such as QGIS was used to process forest reserve and administrative boundary datasets. Overlay analysis and map visualization methods were applied to identify spatial patterns and clearly illustrate the locations of forest reserves. Next is attribute table. Geography Information System (GIS) software was utilized to process, manage, and analyze spatial data related to forest reserves in Malacca. Forest reserve datasets were overlaid with administrative boundary layers to assess their spatial distribution across different districts and administrative areas. Various map symbology and visualization techniques were applied to clearly distinguish forest reserve areas from surrounding land use, enhancing map readability and enabling clearer interpretation of spatial patterns and relationships. Next is Choroplast Map. Various GIS tools and functions were used to enhance spatial analysis and interpretation. These include layer management, overlay analysis, and adjustment of symbology settings. Through this process, the GIS map clearly shows the location and extent of forest reserves as well as their spatial relationship with different administrative districts. Next, WebGIS. The findings from GIS analysis reveal that forest reserves in Malacca are highly concentrated in specific areas, whereas other districts exhibit relatively low levels of forest reserve coverage. This uneven spatial distribution suggests an imbalance in environmental protection across the state, with some areas being more vulnerable to environmental pressures than others. The GIS-based visual outputs makes these patterns clearly observable, allowing for the identification of districts that may require enhanced conservation measures, closer monitoring, or more sustainable land use planning to support long-term environmental management. And lastly, full map. The spatial information produced through this GIS analysis provides valuable support for environmental management and spatial planning initiatives in Malacca. Relevant authorities can utilize these findings to more effectively monitor the extent and distribution of forest reserves, develop targeted conservation and rehabilitation strategies, establish appropriate buffer zones, and reduce the risk of encroachment into protected areas. In conclusion, GIS proves to be a powerful tool for analyzing and visualizing the spatial distribution of forest reserves in Malacca. The use of open government data from data.gov.my improves data reliability and promotes transparency. This project highlights the practical application of GIS in addressing real-world environmental and spatial challenges while supporting informed decision-making for sustainable development.
Digital Skills Showcase. Digital Skills Showcase, it shows how digital tools and technology are used to analyze data and create useful outputs. Attribute data preparation involves reviewing the attribute table and adding a new field called forest reserve. This field was used to store forest reserve values for each state. Proper data preparation ensures accurate GIS analysis and meaningful map visualization. In this part, a color map was used to visualize the distribution of forest reserve across Malaysia. The forest reserve attribute was classified into several value ranges and displayed using a graded color scheme. Each color represents a different level of forest reserve coverage. Lighter colors indicate areas with lower forest reserve values, while darker colors show areas with higher forest reserve coverage. This allows clear comparisons between states. The color map makes spectral patterns easy to identify and helps highlight regions that may require greater attention for conservation and environmental planning. In this stage, the GIS project is developed as a web GIS using the QGIS2 web plugin. The map is exported into a web format, allowing users to interact with the data through a web browser. Users can zoom, pan, and explore the distribution of forest reserves without needing GIS software. This improves accessibility and data sharing.
In conclusion, GIS is an effective tool for analyzing and visualizing spatial and environmental data. Desktop GIS, such as QGIS, allow detailed analysis and map production, while WebGIS makes spatial information more accessible through online platform. Overall, this project helped us improve our understanding of GIS tool, workflow, and their real-world application. Thank you.